How to balance a redox reaction in basic solution with Jackson. We'll be balancing iron hydroxide plus O2, yielding iron hydroxide. First, let's identify what's being oxidized. Iron is being oxidized from Fe2 plus to Fe3 plus. Our first step in balancing this reaction is writing the half reactions. So we're just pretty much going to cut the equation in half. We have iron hydroxide yielding iron hydroxide. That's the first half reaction. And then half reaction B, we have O2 yielding nothing. Next step is to balance the atoms for each half reaction, using H2O to balance for the oxygens and hydrogen to balance for the hydrogens. So for half reaction A, we must balance the oxygens on the reactant side because we have 3 oxygens on the product side and only 2 on the reactant side. So we will add 1 H2O. We now have 3 oxygens on each side of the half reaction. But wait, we now have 4 hydrogens on the reactant side and only 3 hydrogens on the product side. So we must add 1 hydrogen ion to the product side in order to balance hydrogens and oxygens. We now have 4 hydrogens and 3 oxygens on each side of the half reaction. Moving on to half reaction B. We have O2 yielding nothing. So in order to balance the oxygens, we add 2 waters to the product side. We now have 2 oxygens on each side of the reaction, but we do not have an even number of hydrogens on each side of the reaction, so we have to add 4 hydrogens on the reactant side in order to balance it. We now have 4 hydrogens and 2 oxygens on each side of the reaction. Next, the charges on each side of the equation for each half reaction must be balanced. In order to do this, we use electrons to balance the charge. So, for the first half reaction, we add 1 electron to the reactant side, since we have a positive charge on the product side. This gives us a neutral charge for the entire reaction. Half reaction B, we have 4 positive charges on the reactant side, so we must add 4 electrons to the product side in order to balance the charge for this half reaction. Both half reactions are now neutral, but they have a different number of electrons. The number of electrons on each half reaction must be equal in order to combine the reactions. So what we do for half reaction A is multiply the entire equation by 4 to get 4 electrons. But since the entire equation was multiplied by 4, this gives us 4 electrons plus 4 waters plus 4 iron hydroxides, yielding 4 iron hydroxides plus 4 hydrogens. The reactions can now be combined because the amount of electrons on each side is equal. The combined half reactions are going to be 4 electrons plus 4 waters plus 4 iron hydroxides plus 4 hydrogens plus O2, yielding 4 iron hydroxide plus 4 hydrogens plus 2 waters plus 4 electrons. We now cancel anything that is equal on each side of the reaction. So the first thing we'll cancel is the 4 electrons. 4 electrons on the reactant side and 4 electrons on the product side. The next thing we'll cancel is the hydrogens. We have 4 hydrogens on the reactant side and 4 hydrogens on the product side. Those cancel. Now, we have 4 waters on the reactant side and 2 waters on the product side. Therefore, we can only cancel a total of 2 waters on each side of the reaction. We are now left with the full balanced equation. 4 iron hydroxide plus O2 plus 2 H2O, yielding 4 iron hydroxide. Balancing redox reactions.